name is Dr. Esther Trufan, and in this video, I'm going to demonstrate how to collect a full spectrum to determine the wavelength at which we will be performing our kinetics measurements. For this experiment, we're going to need our previously prepared blue food dye solution. That's right here. We will be using some deionized water, and that will serve two purposes. One, to dilute the blue food coloring solution for our measurement, and the second will be to calibrate our instrument. We will need 2 cuvettes, and we will be touching only the ridged sides of those cuvettes. Both cuvettes will require a cap. And to add the appropriate amounts of water and blue food dye solution, we will be using 2 syringes. Because it is nearly impossible to get into the long neck of the volumetric flask with a syringe, we will be using a beaker to facilitate that process. And to collect our measurements, we will be using a spectrometer that is connected to a device. For us, the spectrometer will be a Vernier Go Direct spectrometer, and this will be connected wirelessly to my iPad. The first thing we're going to do is download the spectral analysis app, which we will then open up. Then we'll press the button on the side of our spectrometer, which will light up the green light, and there will be a blinking blue light. Then on our connected device, we'll press Connect a Spectrometer. If you have multiple spectrometers turned on at the same time, you may see multiple of those near your device. Please make sure before you press Connect that the ID listed on your device and the ID of your spectrometer are a match. Once you do that, press Connect, and it will take a couple seconds for the connection to be established. Once the connection is established, we will need to calibrate our instrument. And to do that, we're going to press Advanced Full Spectrum. We need to place our sensor in the appropriate mode today. We will be focusing on absorbance. So I highlighted absorbance, and we press the Calibrate button. This will require the lamp to warm up, which gives us some time to pour some deionized water in one of our cuvettes. Away from our electronic devices, we are going to pour between 1/2 and 3/4 of the way full into the cuvette with just deionized water. Once we've done that, we place a cap on the top and we wait for the lamp to warm up before we proceed any further. Once the lamp has warmed up, it will tell us to place a blank cuvette into the device. We're going to place the cuvette with the clear sides pointing towards the white arrow and the white light bulb. At that point, on our connected device, we're going to press Finish Calibration, and it will indicate that calibration is ongoing. Once the calibration completed, we're going to take our blue food dye solution and transfer a small amount of it into our beaker. Then we're going to take our cuvette, place it closer to the beaker, take one of our syringes, and extract 1.5 milliliters from our beaker. If there are bubbles, we need to push the solution out and try again. And just like with everything else, we want to make sure that the bottom of the plunger is at the 1.5 milliliter mark. Once we got there, we transfer our solution into our cuvette. And we can set our syringe to the side. Then we're going to extract the same amount of deionized water into the cuvette, and we're going to use another syringe. With the same amount of water, we transfer it into the cuvette, and now we place a cap on the top. Holding our cuvette from the ridged sides, we're going to place it into our spectrometer, the same way we place our blank cuvette, and we're going to collect the absorbance data. We're going to go to the top left of our page on the display, select New Experiment, then we'll press the down arrow under Absorbance, And when it pulls up the three options, we will select the top one, versus wavelength full spectrum. When the page opens, we press collect, and a spectrum will be automatically generated for us. Once we press stop, that data is finalized. There are two ways in which we can find the maximum absorbance and the associated wavelength. The first one is to just click or press on the screen on the spectrum and then move our fingers along the spectrum. On the top in red numbers, we are going to see the absorbance value, and on the bottom in black numbers, we're going to see the associated wavelength in nanometers. Now, in this case, we find that our maximum wavelength is 630.3 nanometers, and the associated absorbance is 0.925. With this, we have our starting point for our next steps in this experiment.